Hi all, this is Lakshmi working as assistant professor in the Department of ECE at SNS. So today I'm here to discuss about the design thinking approach for the topic smart irrigation. So let us apply the concept of design thinking and discuss about the smart irrigation using Raspberry Pi. So here first let us consider the problem statement as here in the current scenario in the rising population, the agriculture production is needed. So the irrigated agriculture is very important source which increases the yield, that is the production and its value. So agriculture is the art and science of cultivating the soil, growing crops and raising the livestock. So here the irrigation accounts for 70% of water use worldwide. So if little amount of water is wasted, it will result in huge loss. So the main goal here is to save the water and do the efficient irrigation for agriculture. So we are going to apply the concept of design thinking and identify a better solution for this problem defined. So, design thinking approach is a way of problem solving. It is a human centric approach where we solve the problem by considering each and every need of the end user. So, we consider the emotional, social need of the end user. So, here there are 5 stages. So, first stage is empathy. Second stage is define. So, in stage 1, empathy, we focus towards the need of the end user, and stage 2 is define. Stage 3 is ideate, so where the proper idea for the problem is identified and the solution is given. And a prototype is we create a model for the solution generated and we check for the proper output. So that is called testing. So the next stage is testing the prototype and then is to implement. So these are these major 5 stages of design thinking approach. We understand, we explore, and we materialize. So first, let us discuss about the stage 1, that is empathy. So here, the smart irrigation is an intelligent water management system which automatically monitors the soil and environmental condition and supply the water to plants only when required. So by integrating the Raspberry Pi with sensors, pumps, and communication models, the system helps conserve water, reduce human effort, and improve the crop productivity. So here, before implementing these steps, we have to first analyze the need of a farmer, the people, etc. So here, what the farmer point of view, how they think. So irrigation through the bore wells is not sustainable since there are chances of their drying up during summer. So we cannot use that. And certain the farmer uses 75% of the water to carry out the irrigation. So here they are unable to pay the bank loans for the major problem related to the irrigation, and also to the this problem is leading to farmers suicide as well. So improving the irrigation techniques will help the farmer. The flood irrigation needs more water. So deep irrigation is the most expensive irrigation. Sorry, deep irrigation is the most expensive irrigation. So here the usage of the smart system, it should be very flexible for the farmers to use. When there is a need, irrigation has to be done. When there is no need, it has to automatically control the irrigation system. And based on the type and type of the plants, the crops, the amount of water has to be controlled accordingly. So all these factors are to be efficiently monitored and it is carried out easily, and it should be user friendly for the farm. So coming to the define phase in design thinking for smart irrigation. So as we have initially defined the problem statement, so this smart irrigation sets the stage for generating innovative solution that address real user needs and create meaningful experiences. So this system will collect information from the sensors and sends to the predefined user orders to the activators, and it makes the water sprinkle to you. So data is collected by moisture sensor. So user defines the moisture and the temperature range. So this is how the problem statement here is defined. So ideal. So this is the stage where a proper solution is given to the problem defined. So with the range of generating various ideas and choosing the best idea for implementation comes under ideate stage. So here, as we have discussed, the main objective of the smart irrigation is to reduce water wastage, to automate irrigation process, to monitor soil moisture continuously, improve the crop yield, and minimize the manual intervention. So here we are going to use Raspberry Pi as our controller, central controller. This is a low-cost single board computer which is capable of running a complete operating system. So this board support Python programming, and it has Wi-Fi, Bluetooth, and various communication protocols. So the working principle here is the soil moisture sensor measure the water content in the soil. Raspberry Pi receives the sensor data, and the measured values are compared with the predefined threshold values. If soil moisture falls below the threshold, the Raspberry Pi activates the water pump through the relay module. And if when sufficient moisture is achieved, the pump automatically turns off, and data can be displayed locally or uploaded to the cloud platform for remote monitoring. So this is the ideate phase. And the next phase is prototype. So here, creating a rough model of the solution to check whether it is working properly, we generate a prototype. So here, the prototype is given. So this is the big part of a design process of anything. So we have to figure it out whether this building the right thing and this works out and give us the correct product. So testing is that prototype generated is next move to the testing phase, whether this product is working according to the need as per the design which is generated. So here there are two types of testing discussed. One is uniformity and the other one is pump or well testing. So here uniformity testing is troubleshooting procedure to check that the water is distributed by the irrigation system and it is being applied uniformly to the field within practical limitation. And in case of pump or well testing, the pump testing is done in an open discharge method. The pump is disconnected from the irrigation system and the flow meter. The pressure indicator, the valve is installed on the pump out. So the pump is started and the valve is closed until the design pressure is reached. And generally for 15 minutes it is run and the valve is open and closed. So this is how the testing procedure is done. And today's assessment. So what is the future of smart irrigation? So the future smart irrigation looks like integration with artificial intelligence. So that would analyze whether the data and it predict the future water needs. Thank you.